Okay, so this is learning outcome 4, question number 3 for the year 1 exam, and it's the use of what we've been doing in questions 1 and 2 effectively to find out the solution to some simultaneous equations. We could solve these simultaneous equations either by elimination or by substitution algebraically, but the beauty of this method is that we're using matrices. We can plug this into a program like Excel or into a computer, and it will work out I1 and I2 directly for us. So this is one big use of matrices. Also, they can be used to solve much more complex problems, and it reduces an algebraic problem to one where we just have to grind out the result using a particular method, and that's what you've asked to do here. So again, you need to remember the method to do it. So the first step is to put this information into the form of a matrix form. So first of all, if we take over the numbers, the 14.6 and the 2.06 over to the other side, we get 2i1 plus 5i2 equals minus 14.6. And then we also get that 3.1i1 plus 1.7i2 equals minus 2.06. So now we can write these in matrix form. 2, the matrix 2, 5, 3.1, 1.7, and those are the numbers that appear here, if you look at them, multiplied by I1 and I2, give me minus 14.6 and minus 2.06. And if you think about this, this actually agrees with, if we look at multiplying out these matrices on the left hand side, we would get the solution on the right. So in other words, if I do write 2 times I1 plus 5 times I2, I would get this first equation here, and that equals minus 14.6. And similarly, using the bottom element on the first matrix, 3.1 times I1 plus 1.7 times I2, which is the second of these equations, must equal minus 2.06. So you can see it works if you look at it. Now it's in matrix form. We use the idea that if we call this matrix A and we multiply it by its inverse, which we're going to find, the inverse or reciprocal, then times that by I1, I2, that will equal the inverse of that matrix multiplied by minus 14.6 over minus 2.06. And then we remember that this times this is the unit matrix 1001, which is effectively 1 in numbers, but it's the unit or the number 1 in matrix form, which in other words means we'll be left with I1, I2 equals I1 effectively I2 times the unit matrix equals A to the minus 1 minus 14.6 minus 2.06. That's the idea. So if we can find this and multiply that by the solution, then we'll end up with values for I1 and I2. That multiplication will give us I1 and I2. So that's the idea. So let's carry on now and have a look at the question. So rewriting this matrix, well, then at the top here, I'll then have a go at multiplying it out. Find the determinant, find the reciprocal, having found the determinant, and then do this process. See if you can carry it on and complete it. I'll put the question as a solution below. Okay, so to find the inverse of this matrix here, we have to follow the same steps we did in question number 1. We have to find the determinant. So the determinant of this matrix, 2, 5, 3.1, 1.7, equals the leading diagonals multiplied together, just reduce this, 2 times 1.7 minus the other diagonal, 5 times 3.1, and that turns out to be minus 12.1. So that's the determinant of the matrix. Now, to get the inverse, what we do is we take this top matrix here and swap over the leading diagonal and change the sign on the others. So the inverse turns out to be 1.7, 2, swapping those over, and then changing the signs of these, minus 5 and minus 3.1, and then dividing each of these elements by minus 12.1. And that will give us the inverse, which turns out to be minus 0.14, 0, we've used 3 significant figures, 0.413, 0.256, and negative 0.165. See if you can work, see if you agree with that solution, and then carry on and see if you can complete the question. Now we've got the inverse, we can then go back to what we were talking about at the start of this question here and try and work out what I1 and I2 are. Again, I'll pause it here and then carry on and do the solution for you. Okay, so you might want to confirm, you don't need to do this, particularly certainly not in the exam, but what we're saying is that A times by its inverse equals the unit matrix. So you might want to confirm that. But taking this as the case, then first of all we can say on the left-hand side of this equation, A times A, the inverse of A, gives us the unit matrix. And so that then is multiplied by I1, I2, equals the inverse matrix multiplied by this solution, minus 14.6 over minus 2.06. So if we multiply out these matrices on the right-hand side, remembering how to multiply out the matrices, it's this element times this, plus this times this gives us the top element here, and then for the bottom element, negative 3.4, 0.256 times the top, plus that one times that one gives us the bottom. And so multiply out those matrices and confirm that I1 over I2 equals 1.19 over negative 3.4. So those matrices must be identical. Therefore, I1 equals 1.19 and I2 equals negative 3.4. Negative in the sense that it's flowing the other way conventionally in our circuit. So I1 equals 1.19 amps and I2 equals negative 3.4 amps.